Clouds play an important role in many computer games, particularly flight simulators, where the user spends most of his time in the sky. We present a system of creating and rendering clouds that look realistic with fast performance. It forms and dissipates clouds, and also scales to a variety of cloud types, such as stratus and cumulonimbus. Our system is used in a commercial flight simulation game. Artists use 3D Studio Max to build cloud models, then export them to the game, where they are rendered and shaded. In 3D Studio Max, artists use boxes to build the cloud's shape. When they press a button on our custom-written Max script, the script fills in the boxes with randomly placed sprites. The artist can manipulate these boxes in 3D Studio Max and see the cloud change. This immediate visual feedback is very important to creating high-quality content. Using the script's UI, the artist can control the number of sprites, sprite size, distribution of textures, and other properties. We use a single texture sheet to create many cloud types, using blurrier textures for stratus and more detailed ones for cumulus. When finished, the artist exports the cloud into a file to be loaded into the game. Here we see a scene of clouds rendered in the game. Note how the clouds look good from a moving camera position, which is important for games. The clouds are drawn as clusters of sprites, each sprite facing the camera. These are the same sprites that the artist sees in 3D Studio Max. Our system also looks good when the camera passes through the cloud. As the sprites pass the camera, it looks as though puffs of the cloud are going by. We do not use a canned animation like many other games, which means each of our in-cloud experiences is unique and matches the way the cloud looked from the outside. We can model many types of clouds. Here are a few examples. A large cumulonimbus cloud surrounded by small cumulus. A dark raining nimbostratus layer below cumulus mediocris clouds. Two layers of altocumulus clouds. We can make clouds dissipate by increasing the transparency of the sprites. We do this for the sprites on the edges first, then the core. This looks as though the outer puffs are dissolving, leaving the core, which then also fades. Cloud formation is the opposite of this process. We use a simple shading system rather than model the scattering of light from cloud particles. This trade-off causes some shading inaccuracy in exchange for fewer computations and more artistic control. Light from the sky is absorbed as it filters down through the cloud, which gives clouds darker bottoms. We simulate this by having artists specify several colors associated with vertical heights in the cloud using 3D Studio Max. In the game, we compute the sprite's vertical position along the cloud height and shade it. This gives clouds darker bottoms. To model sunlight, we shade parts of the cloud facing the sun with more directional sunlight than parts facing away. Our artists use sliders to set the color and intensity that the sun casts on clouds for different times of day. Our system produces vivid images at sunrise and sunset. For performance, we dynamically render faraway clouds into imposters. Here we turn off all clouds, render just the imposters, and now render 3D and imposters together. You can see there's no visual difference between clouds rendered in 3D versus the imposters. As you've seen, clouds are a big part of the scene in a computer game. Our cloud system brings the realism and graphics up to a new level.